Assalamu alaikum dear students. Yesterday we discussed the differentiation of or the derivatives of logarithmic and exponential function. Today we will discuss the logarithmic differentiation. Now what is logarithmic differentiation? To which functions we apply this logarithmic differentiation? Let f of x equals to u raised power x u of x raised to power v of x. This means that this is the function which is a power of two functions. Here we have to find f dash of x provided this f dash of x is positive, means at each and every value of its domain f of x is positive, means value of f of x is greater than 0, that is this is the positive function. Now when we take logs on both sides, because here f is positive means log is defined, which implies that log of f of x equals to log of u of x raised to power v of x. Here this log is the natural log, means its base is e, which implies that log of f of x equals to v of x into log of u of x, by considering log of m raised to power n is n log m. Now when we differentiate it, you know that differentiation of log of x is 1 upon x, which implies that it is 1 upon f of x, because differentiation of log is 1 upon f of x. Now differentiate this f of x, that is its differentiation is f dash of x. Now here we have two functions, one is v of x, second one is log of u of x. So we have two functions. We have a function, we have to find its derivative, which is product of two functions. So simply use the product rule of differentiation, which states that the differentiation or the derivative of the product of two functions is equals to first function into derivative of second plus second function into derivative of first function, which simply equals to f dash of x upon f of x v of x. Now differentiation of this log of u of x is 1 upon u of x into u dash of x, because just like here log of f of x. Now log of x, now differentiation of v of x is v dash of x, which implies that simply f dash of x equals to fx by cross multiplication into v of x upon u of x into u dash of x plus v dash of x into log of u of x. So this is the differentiation, means this is the derivative for this function, which is of the form of u of x raised to power v of x. Here this u and v, they should be not the simple functions. Like if we consider the function of the form of x raised to power 5, although it is of the form of u of x raised to power v of x, okay, but for such functions we have already a rule, that is x raised to power n rule. So this means that we are using this rule for those functions which are positive. Second, which are something the complex functions, like sine of x raised to power sine of x. So here we cannot use x raised to power n rule. So this means that this rule or this differentiation is applicable for such functions. Now if we consider y equals to a raised to power x, where a is a positive constant, now we can use here this logarithmic differentiation, which implies that taking logs and using this log a raised to power x is x log a, which implies that log y equals to x log a. Now when we differentiate it, it is simply 1 upon a 1 upon y, because differentiation of log is 1 upon y, and differentiation of then again differentiate this y, which is dy upon dx. Now this log a is constant, or we can take this as a constant function and use the product rule of differentiation, or simply this log a is constant, x is variable, which implies that its differentiation is simply log a into 1, because or use the product rule and taking log a as the second function, which implies that its differentiation or its derivative is dy by dx equals to y by cross multiplication into log of a. Here y is a raised to power x, which implies that It is differentiation is ax log a. This means that differentiation of a raised to power x is ax log a with base e, by considering only the natural log, means L and nil. Example, if we consider y equals to 5x, it is differentiation is by above 5 raised x into log of 5. Here this a or this 5 should be positive. If it is negative, so this means that we cannot define the log for the negative numbers. Now if we consider a situation where we have a function which is a product of the two individual functions, then we can simply use the product rule of differentiation. Now if we have a function which is a product of three functions, then in this case we can also use this logarithmic differentiation. Like if we consider a function y which is product of three functions u, v and w, by taking logs, you know that log of m into n is log m plus log n, which implies that log of u of x, v of x, w of x is log of u of x, log of v of x, log of w of x. So simply differentiate this equation, we get 1 upon y dy by dx. Now log of u of x, its differentiation is 1 upon u of x into u dash of x. Similarly here, v dash of x upon v of x, w dash of x upon w of x, which implies that dy by dx is y into u dash of x upon u of x, v dash of x upon v of x, w dash of x upon w of x. So this means that this is the derivative for such function which are the product of three functions or four functions or five functions. If we have simply two functions, then we can use the product rule of differentiation, which is actually the same, which is actually the logarithmic differentiation, but in simplified form. Now let me consider an example of this type, that is y equals to cos x into cos 2x into cos 3x. Here these this y is product of three functions, cos x, cos 2x and cos 3x. Now considering cos x or cos 2x or cos 3x only positive, which implies that taking logs on both sides, log y equals to log of cos of x, cos 2x and cos 3x. Now this right hand side becomes log of cos x plus log of cos 2x plus log of cos 3x. By using log m into n is log m plus log n. Now which implies that by differentiating above equation, we simply get 1 upon y dy by dx. Now differentiation of this log is 1 upon cos of x. Okay, now then we have to differentiate this cos. Differentiation of cos is minus sign, that is minus sign upon cos. Now here differentiation of this log is 1 upon cos 2x, that is this 1 upon cos 2x, which is in denominator. And differentiation of cos is minus, that is minus sin 2x. Then again differentiate the angle of this trigonometric function, that is 2x, its differentiation is simply 2. For this log of cos 3x, its differentiation is minus sin 3x upon cos x into 3, which implies simply minus tan x, because sin upon cos is tan, minus 2 tan 2x minus 3 tan 3x, which implies that dy by dx is y into minus tan x minus 2 tan 2x minus 3 tan 3x, or dy by dx is minus y into tan x plus 2 tan 2x plus 3 tan 3x. But y is this cos x, cos 2x, cos 3x. Now substituting in this equation, we simply get dy by dx is this. So this is the derivative for this function, which is product of three functions, and we find this dy by dx by using the logarithmic differentiation. Now if we consider this irrational function like y equals to under root or square root or under root of x minus 1 into x minus 2 upon x minus 3, x minus 4, x minus 5. Here this is x minus 1 into x minus 2 upon x minus 3, x minus 4, x minus 5 raised power 1 by 2, because under root simply means index is 1 by 2. Now here the term within the square root is positive. Now if it is negative, this means that under root is not defined. This means that this must be positive, which implies that when it is positive, we can apply the log, which implies that log of y equals to log of this very term. Now using log m raised to power n is n log m, which simply equals to log y equals to 1 upon 2 into this, or 2 log y by cross multiplication is log of x minus 1 into x minus 2 upon x minus 3 x minus 4 into x minus 5. Now this simply equals to twice log y. Now it is log m by considering numerator as m and denominator as n, which implies that log m minus log n, that is log of x minus 1 x minus 2 minus log of x minus 3 x minus 4 x minus 5. Now log of m into n is log m plus log n, which implies that it is log x minus 1 plus log x minus 2 minus log x minus 3. Now here it is log of x minus 3 plus log of x minus 4 plus log of x minus 5. But outside this we have negative, which implies that each and every term becomes negative. Hence it is minus log x minus 3 minus log x minus 4 minus log x minus 5. Now differentiate these terms, or differentiate this equation with respect to x. Now it is 2 is constant, so differentiation of log is 1 upon y into dy by dx. Now differentiation of this log is 1 upon x minus 1. Then we have to differentiate this x minus 1, its differentiation is 1. Similarly, it is 1 upon x minus 2 into 1 minus 1 upon x minus 3 into 1 minus 1 upon x minus 4 into 1 minus 1 upon x minus 5 into 1, because differentiation of log of x minus 5 is 1 upon x minus 5 into differentiation of x minus 5, which is 1. Hence it is simply 1 upon x minus 5 into 1. Now which simply equals to, by simplification, dy by dx is y by 2 into 1 upon x minus 1 so on to minus times 1 upon x minus 5, while y is under root of x minus 1 into x minus 2 upon x minus 3 into x minus 4 into x minus 5. This means that the derivative for such functions is this, by using the logarithmic concept. Now we have another function or another problem, y equals to log of x into cos of x. Here this log x is always positive, which implies that taking logs on both sides, it is simply log of y into log x raised to power cos x. Now using this m raised to power n rule, it is log y equals to cos of x into log of x. Now we can use here the product rule of differentiation, which implies that by differentiating 1 upon y is dy by dx equals to, now first function into differentiation of second. Now it is differentiation, log of log is 1 upon log of x into 1 upon x plus log of log x into differentiation of this cos is minus sign, by using the product rule of differentiation and considering cos x first function and log of log x second function, which implies that 1 upon y dy by dx is cos x upon x log x by multiplication here minus times sin of x log x, which implies that dy by dx is y cos x upon x log x minus sin x log x, which implies dy by dx is y is here log x raised cos x, which implies that log of x raised cos x into cos x upon x log x minus sin x log log x. So this means that you can now inshallah tomorrow we will continue this very topic. So thank you.